In this video, we're going to use epsilon-delta definition of limits to understand one-sided and infinite limits. It says, what values of delta are an appropriate choice when proving the following limit? And they give you the limit as x approaches 5 of 5 divided by x minus 5 squared is equal to infinity. So let's write out some things that we know here. We know that the limit is going to be infinity. We know that f of x is 5 over x minus 5 squared, and then we know that our a value is 5. So let's write down what the definition is for let's write down the definition for the infinite limits for epsilon delta. So we can say that the limit as x approaches a of f of x is equal to infinity if for every or for any m value greater than 0 there exists a delta greater than 0 such that 0 less than absolute value of x minus a is less than delta implies f of x is greater than our m value. So we're going to use this definition to basically prove that this limit is equal to infinity. So how do we start? Well, we're going to start with the implied piece. So we're going to start with the implied piece, figure out what we need, and then we're going to set delta equal to that value. So we're going to say that 5 over x minus 5 squared is greater than m. And then we're going to start to solve this. So we're going to take the reciprocal of each side to start. So I'm going to say that this is really equal to if I reciprocal the left side, that'd be x minus 5 squared over 5. And then the sign would change here, so that's less than, and that would be 1 over m. If I multiply by 5 on each side, I would end up with x minus 5 squared less than 5 over m. If I square each side, then I would have absolute value of x minus 5. And I say the absolute value of x minus 5 because if I'm square rooting, sorry I said squaring, if I'm square rooting each side, this was already a squared term, and when we square root, we're not going to get the negative version of that, we're going to get the positive version of that. So that would just be an absolute value of x minus 5 less than square root 5 over m. And so we're at this spot where we have x minus a, which a was 5, and we know x minus a is less than delta, so we can say x minus 5 is less than delta. So we're going to now choose delta to be equal to root 5 over m. And so because we chose delta to be equal to root 5 over m, we're now going to start with this piece, and we're going to prove that this piece is true. And if we do that, then we've completed our proof that the limit as x approaches 5 for this function would equal infinity. So once we choose this, we're now going to say absolute value of x minus 5 is less than our delta that we chose, which is root 5 over m. And I'm going to say that this is the proof. We're going to square each side, and if you square a value that's going to be positive, absolute value is going to give you positive. We can just get rid of the absolute value signs. So we can say that that's x minus 5 squared less than, we square this side, we get 5 over m. We're going to take the reciprocal of each side, so that's 1 over x minus 5 squared greater than, this would be m over 5. And then we're going to multiply by 5 on each side, so we get 5 over x minus 5 squared greater than m. And so this is our f of x greater than m piece. This is the piece that we started with, right? We started with this piece, found a delta. We chose that to be delta, and then we worked backward and proved that we got back to where we originally started. So this would be the proof that the limit as x approaches 5 for 5 over x minus 5 squared is equal to infinity. Now in the problem they ask you what the values for delta would have to be. What would be the appropriate choice? Well, our appropriate choice would be delta being root 5 over m.